Hello, my name is Leslie Lusko. I'm an associate professor here in the Department of Integrative Biology, and it is my distinct honor to get to introduce Professor Nina Jablonski today. For those of you who were able to attend her talk yesterday, you've heard of her academic accomplishments. She did her undergraduate work at Bryn Mawr. She got her PhD from the University of Washington. She then moved in, became an anatomy instructor at the University of Hong Kong. She was a lecturer at the University of Western Australia, and then a curator of anthropology at the California Academy of Sciences, and then served for a while as the head of the Department of Anthropology at Penn State University, where she now has the luxury of just being a full professor and all that comes with that. She's had numerous research grants, support that came from the National Science Foundation, the Wallenberg Foundation, the Robert Wood Johnson Foundation, the Rockefeller Foundation, and her accolades include, some of the most recently, membership in the American Academy of Arts and Sciences, among many, many others. So as you know from this lecture series, she is well known for her work on the evolution of human skin color and is deeply admired for her talent in conveying this excellent research to the public. But she's also highly respected to those of us in academia for her meticulous paleontological research in Asia and Eastern Africa. And it is this less famous side of her research over the years that had initially brought the two of us together. Now, all of us in this room, if we're lucky, we have a small handful of people who have served as an inspiration or role model in our lives, people who we hold up as our intellectual heroes. Nina is mine. We first met years ago when I was a graduate student studying baboon teeth, and she graciously gave me some of her time and even gave me a copy of a beautiful monograph that she had edited about these magnificent animals. And I remember clutching that book to my chest with pride and excitement the whole way home that day. So Nina has continued over the intervening years to be my validation and inspiration, and her opinion has always mattered more to me than that of anyone else. But more than that, for all of us in academia, her research and outreach efforts on the evolutionary history and importance of skin color variation is a beautiful inspiration to follow. So Nina, thank you for being a shining light in our discipline, and thank you so much for spending this week with us in Berkeley. Thank you.
Thank you, Leslie, for that beautiful and generous introduction. Thank you to the Hitchcock Lecture Committee, of which there are at least a few representatives here, for their gracious and generous invitation and for really making possible several wonderful days of intellectual feasting on my part with accomplished faculty and students. Studying human skin and skin color has been one of the most rewarding possible adventures that I think any scholar could have. From our early studies of the evolution of skin pigmentation, many research programs have flowed. In short, we can understand human skin really quite simply. The skin pigmentation that we see so beautifully arrayed in a geographic pattern is not random. It evolved as the product of natural selection. 86% of variation in the skin color of indigenous peoples can be explained by variation in ultraviolet radiation. So we have in human skin a beautiful example of evolution acting on the human body. And we understand that skin pigmentation is an evolutionary compromise between the demands of protecting against very strong solar ultraviolet radiation at the equator and the equally important demands of being able to continue to produce vitamin D in the skin, and I will advance today other arguments, but continue to produce vitamin D in the skin under conditions of low ultraviolet radiation closer to the poles. In the terms of evolutionary biology, what we have here are two clines. And in the intermediate zone, here and here, we find lots of people of intermediate pigmentation who are able to gain and lose pigmentation season to season through tanning. We now recognize not only this phenotypic pattern, the appearance, but we understand a lot of the genetic architecture. Today, I want to talk more about what this means. A few decades ago, the Brazilian artist Angelica Das started to compile what she called a chromatic inventory of her fellow Brazilian citizens, people who came in every range of sepia coloration. She wanted people to appreciate just how similar we were, how much our colors graded beautifully into one another, that there was no discontinuity in the colors of humanity. And so today, what I want to do is to develop more of our own, as well as that of others, research on the meaning of skin color, what it means to us as social organisms, as social primates, and what it means to us with respect to our health. It's important to recognize when we think about the social meaning of skin color today, often we use the term colorblind, or we should be colorblind. Well, from the literal perspective, we can't, because we as catarrhine primates, as monkeys and apes, are endowed with superb trichromatic color vision that allows us to see beautiful richness of color in very high definition. So we notice color. We can't help but notice color because of our trichromatic color vision. So that's really important. We're visually oriented animals. The color of our fellow human beings, the shape of their bodies, all of these physical features are important to us because we're visually oriented animals. So that's an important thing to think about from a cognitive, behavioral perspective. How did people start interacting with one another, people who had different skin colors, in the course of human history? We don't know a lot about these early interactions. Some of the best written and artistic records that we have actually come from ancient Egypt. We know that there were extensive interactions at many times in Egyptian history, extensive interactions between peoples in the upper and lower Nile, peoples who were mostly very darkly pigmented and moderately pigmented or quite lightly pigmented in the north. The salutary message from all of these interactions is that trade occurred. There were lots of diplomatic exchanges, artistic exchanges, and although there were conflicts and there was warfare, these were not on the basis of any color distinction, but rather of inequities of resources or trade imbalances and other various kinds of disagreements that might exist between sort of any polities in time. Very importantly, the idea of calling another group other because of color did not exist to our knowledge. This is not to say that we didn't engage in what Michael Omi and many other scholars have called the process of othering, the process of racial formation. If we go back again in ancient history to look at the interaction between the Greeks and the Persians, for instance, the Greeks referred to the Persians as barbarians. They were distinctly defined by their language, by their dress and their customs as other and as barbarians. in a negative sense. The category of other existed, although it was not associated with skin color. When we think about coming into the more modern Western scientific tradition and how people started to think about human diversity, it's not inappropriate to pick up the story with Linnaeus, because he was one of the first, albeit not the very first, to think about human variation and how we might classify it. Now, what's really interesting and incredibly important to remember is that for Linnaeus and many other European scholars at the time, there was no personal experience with people in foreign countries outside of Europe. Many people, many naturalists, historians like Linnaeus and others, basically stayed at home. I mean, travel was logistically difficult, plus they enjoyed the comforts of their life at home. And they relied instead on information, biological samples, and sort of travel logs that came to them via a series of sources, often from Portuguese, French, Italian explorers. So people like Linnaeus got biological specimens, not so much of primates and humans, although they did get a few primates, but they learned about human variation from stories, second, third, and often fourth hand. And when Linnaeus turned his attention to classifying humans, initially he classified them very simply. 4 groups: Europeans, Americans, Asians, and Africans, separated by what he saw as the cardinal distinction of skin color: white, red, brown, black. No hierarchy, just a list. What happens in the intervening years? Here we are, middle of the 18th century, 1748. 1758, only 10 years later, his description of variation in humans is much longer, and I've only given a little digest here. Significantly, we have the same groups, and the skin colors, again, red for Americans, white for Europeans, brown for Asians, black for Africans. But we also have these other words: choleric, sanguineous, melancholicus, phlegmaticus, describing temperament and behavior. And here, Linnaeus is really referencing Hippocrates, Herodotus, and other scholars of ancient Greece who wrote extensively on human temperaments being formed by the intensity of the sun and their environment. Are people experiencing too much heat, too much cold, too much moisture? Their temperament, their behavior would be formed by their environment. And what's remarkable here is that Linnaeus, the systematist of the natural world, who was describing mosses and monkeys in the most objective, what we would call scientific way, is here describing humans according to their temperament. And this heralds a different treatment of humans that we see elaborated in various ways in the coming decades. The middle 18th century is the seething hotbed of intellectual thought about human diversity. Scholars throughout the Western intellectual tradition are trying to understand, what does it mean when people look different? Are these people all from one source? Are they separate creations? Where did this diversity come from? And what does it mean with respect to people's cultures, their capacity for civilization? And this is where we come to the work of many important philosophers, but I'm singling out here today Immanuel Kant, because Kant holds a special place in the history of philosophy and critical thought. He is lionized rightly for many of his philosophical writings, but early in his career, Kant thought deeply about human diversity. He was trying to understand, why do people seem to have different predilections for behaving in certain ways, to be civilized, different abilities to develop higher modes of thought. And so in a series of writings, beginning in 1775 and concluding in 1788, he is writing on the subject of human diversity, something that very few people recognize. And what he does is he formally constructs 4 races of humans. And he is the first to formally use that term. He uses the German noun Rassen, not race, but these are formal categories. And very significantly, he differs from Linnaeus because these aren't just 4 groups. These are 4 groups that are ordered in the order of their potential for civilization, their potential for developing higher thoughts, for being able to use reasoning. And very importantly, for Kant, these categories were immutable. And once a particular group, for instance, the Negro race as he defined it here, or the Hunnish race, once they developed a certain series of morphological characteristics, including color, that was an irreversible pathway. So he had a very rigid idea, as well as a hierarchical notion of how humans were arrayed. And famously, Kant almost never left his own sitting room. So Kant got information from many of these rich, by then very rich, travelers' tales, and he distilled it in his own way. And he was joined in this slightly earlier in time by the Scottish philosopher David Hume. Hume made less thorough investigations of human diversity, but when you read Hume's writings, one is left in no doubt that he knew who was superior. There was never a civilized nation of any complexion other than white. So even though there were many influential, quite influential detractors in the mid-18th century to Kant and Hume, why did this idea, this notion of human races in a hierarchy, immutable, unmixable, how did this view come to have such popularity to this day? Races for Kant and Hume were physically and culturally distinct from one another, and there was no doubt in either of these men's minds that the so-called white race was superior. This ascendancy we now can look at through the richness of history as being completely understandable. Both of these people were highly regarded. One of the things I'm most interested in is who's managing reputations. In the days before software companies were managing reputations, who managed reputations? Basically, some scholars were highly regarded, their works were widely circulated in particular salons. The information about them was communicated from one scholar to another by correspondence. People, their books became widely distributed largely on the basis of personal circles of influence, to the extent that these two, David Hume and Immanuel Kant, in their lifetimes became very, very highly regarded, and their books were widely distributed and translated. Their writings were taken up by other prominent scholars and by statesmen, so that you have politicians, including politicians in the nascent colonies and the United States, reading these works as well. And we must bring in economics. At this time, this transatlantic slave trade is expanding. There is pressure, especially in England, to lessen or do away with the slave trade, but there's tremendous support from mercantile interests in Europe to continue to promote it, to grow it in whatever ways possible. This is where we begin to see tremendously interesting and, in retrospect, nefarious and tragic alliances between commercial mercantile interests, philosophers, and some very, very bad theology. By the middle 19th century, tracts like this, The Biblical Defense of Slavery, The Origin, History, and Fortunes of the Negro Race, this is just one of many tracts that purport to use biblical sources to prove the inferiority of black people, especially darkly pigmented people from Africa. So what we see between the middle of the 18th and the middle of the 19th century is the imperfect storm of forces, of economic, philosophical, and theological forces, and I want to say quasi-theological forces, because there is nothing in the Bible that talks about discrimination according to color. Stories about the curse of Ham are based on interpretations that are very much culturally influenced interpretations of the Old Testament. So in this century between the mid-1700s and the mid-1800s, we have this maelstrom of forces, not only demonstrating, proving the existence of races, proving the immutability of races, but also proving the inferiority of the so-called Negro race. And further, in some of these biblical defenses of slavery, proving that Negroes were only fit for slavery, they were fit for serving others, and that their biology dictated this. This was a wild time, and we can only recognize now how much we were being manipulated. The boxes basically have text in them showing how the progress from this racial ideation to the creation of racial stereotypes to what I call color memes, in the Richard Dawkins sense of a culturally transmitted idea that acts like a genetic trait. Color-coded race concepts become color memes that are stereotypes. And this lays the clear psychosocial template for racism. So by the mid-19th century, we have color-based racism as the reality in the United States and in many other countries. This reality has been constructed in a way that is completely understandable, but in a way that most people don't recognize, and certainly in a way that most school children in the United States are taught about. When we look at the cost, the human cost of the slave trade, we begin to recognize what is involved here. Nearly 13 million people involved in the slave trade, and from a social perspective, tremendous disengagement, uprooting of peoples from equatorial West Africa primarily into Europe, thence to the Caribbean, sometimes directly to South America, and then a smaller fraction to North America. Nearly 13 million people, and significantly, involuntary migration, the largest influx of people ever to come into the United States. And here we transit to our biology and health considerations. moving people from one solar regime to another. In many cases, moving people from a very, very sunny place to a less sunny place. What consequence is this going to have for health? And further, what consequence are other migrations going to have? Voluntary migrations to this day. What are they having on, what impact are they having on health? And further, what impact is urbanization having? As anthropologists, we tend to think that sort of the world stopped maybe at the beginning of the introduction of agriculture, that all sort of important things in sort of human evolution stopped at that time. I would advance to you that some of the most important biological changes started then. Because as a result of mass migrations made possible by rapid modes of movement, ships, then planes, people able to move dozens of degrees of latitude in hours instead of weeks, or in a few days instead of over many generations or lifetimes, that this physical movement of people, as well as the concentration of people in cities, from fairly modest cities 7,000 and 8,000 years ago to the mega cities of the world today, and a prospect in 20 years of 70% of the world's population being in cities. This is such a dramatic departure from anything previously in human evolution. And today I want to talk about specifically the consequences for our relationship with the sun. Where are we today? We are in a very nice building, far away from the sun. And most of us have spent most of today outside of the sun. This is a great departure from what even perhaps our parents, or certainly our grandparents or great-grandparents, might have done. People who toiled in the fields or worked out of doors, or at least walked to and from work if they lived in cities. These are enormous forces of modern evolution acting on the human body. If we look at just some recent human voluntary migrations, so we're not talking about the mass involuntary migrations of the transatlantic slave trade, but rather, just a sampling of some of the more dramatic migrations. Long distances, often involving people going from areas with very low ultraviolet radiation to high and vice versa, some extremely long distance ones involving great shifts from high to low or low to high UV. We think we're very clever that we can undertake these mass movements. It is fantastically, technologically superb that we're able to undertake this, that people can move around freely over the surface of the Earth's surface, and we have the hubris to think that we can somehow overcome it, or that it doesn't really matter to us as biological organisms because we're so clever. Well, we're not, because there are some considerations, some biological considerations that we haven't given full credence to. Recall that, human behavior in prehistory was very different. We didn't travel very much during individual lifetimes. Certainly people would, at various times, pursue prey animals that would be migrating, and they would go after them, but there were never sort of long distance, or very few long distance migrations of people, and people during their lives would move 10 or 20 kilometers maybe. And they spent most of their time outside, and mostly without sewn clothing. Again, if we only have needles showing up in the archaeological record, sewn clothing, tailored clothing that can protect the body only in the last 20,000 years, what are we doing before that? Yes, we are protecting ourselves with animal skins and probably plant materials, but Skin is our major interface. During most of the major movements and dispersals of human populations, skin is our major interface with the environment. And we, as outside organisms, are under varying ultraviolet regimes. If we're living at the equator, the amount of variation is less than if we're living at this latitude or even closer to the poles, but variation in ultraviolet radiation can be extreme, and variation in solar radiation can be extreme. So our skin has adapted to these changing regimens, and we see biocultural adaptations, not only genetically driven adaptations in skin pigmentation, but cultural adaptations, modification of diet and ways of procuring food so that we can compensate for difficulties posed by the physical environment. But today, holy cow, not only are people dispersing, but they take vacations. Who took vacations 500 years ago or 5,000? The whole concept of a vacation is something that our ancestors never entertained. But today we have all sorts of ways for getting people around. And one of the things that they like to do, especially if they're in indoor jobs, is that they like to find sunny places. And so you have these incredibly depigmented people seeking out sunny places for intense episodes of sun exposure. What a bad idea. So if we just look at a sampling of 21st century vacations, they are many and varied. On a college campus, you know that it's spring break. Kids are going all over the place. People go all over the place. And often in the wintertime, they're seeking out sun, or they're seeking out some interesting cultural experience, often in a sunny place. So we have humans that are moving, not only migrating to live in a particular place, we have them undertaking these short episodic vacations so that they can enjoy leisure time in a different environment. And this is where we really begin to see some of the first untoward aspects of modern life with respect to the skin. The rise of intense episodic sun exposure and the vacation effect. And not just solely sort of going on vacation to a sunny place, but the rise in the use of tanning facilities. Now, I realize there aren't that many tanning facilities in Berkeley, although I did see one the other day as I was walking around. But where I live in central Pennsylvania, they are common. And in many parts of this country, they are extremely common. People like to go there. It feels better to them when they get, quote, sun on their bodies, UV on their bodies. So, without going into excruciating detail, suffice it to say that people pay. In the short term, they pay because they get an uncomfortable sunburn, but in the long term, they pay because of increased susceptibility to a variety of skin cancers, and including if the exposure is intense enough and the genetic architecture of the skin is such, episodic, strong exposures in childhood especially can lead to the most deadly form of skin cancer, melanoma, which was almost unheard of in humans before 1950. So we have this interesting pattern of morbidity and some mortality due to too much episodic sun exposure. But I want to spend more time talking about what happens on the other side of the coin. What happens in big cities where we have, like in New York City here, everybody, every color, every shade of the sepia rainbow represented, every possible ethnicity, most people living indoors. What happens? Like in this Motorola plant in Texas, where all of the workers from whatever background spend all of their time indoors assembling cell phones. These individuals are experiencing different rhythms of nature, a different quality of nature, a different kind of environment than humans have ever experienced. And we now are beginning to recognize what health toll this is taking. Yesterday, I introduced the concept of the vitamin D compromise, how people throughout evolution have developed ways of getting enough vitamin D. At the equator, if you are outdoors long enough, even if you have the most darkly pigmented skin, you will be able to make ample vitamin D to satisfy your physiological needs. But if you spend time indoors, a lot of time indoors, that changes things. If you are a lightly pigmented person, even though you can get a lot of vitamin D produced in your skin in a relatively short period of time if it's in the sunlight outdoors, if you spend all of your time inside, you have no opportunity to make vitamin D in the skin. So the vitamin D compromise, as we have described it, is a compromise that has been worked out more or less by trial and error by cultures in various places over thousands of years, whereby if you're not getting a lot of vitamin D from solar sources, you are getting it from dietary sources. And people living at extreme high and extreme in both hemispheres, northern and southern hemispheres, have cultures that concentrate on the harvesting of vitamin D-rich foods. So what happens to folks today? The vitamin D compromise is mostly broken because we are living indoors in ways that I've described, going to school, going to work. When we do have outdoor sun exposure, it may be in the very early morning or in the late afternoon when there's very little in the way of ultraviolet radiation in the sunlight. So we may feel some benefit from being out of doors, but we're not deriving any benefit from the positive side of ultraviolet radiation exposure. And with reduced time spent out of doors, the combination of being in a city and having an indoor lifestyle is, I wouldn't want to say a deadly combination, but it's a combination that is inviting chronic sickness of various kinds, and I'm going to talk about that. The levels of morbidity and mortality that can now be traced to vitamin D deficiency, and especially chronic vitamin D deficiency, are prodigious. This is now a problem of enormous and global proportions, a significant global health problem. It is, to some extent, understated in this country, but it's certainly not being understated in many other countries, especially in those where a nationalized health system is picking up most of the cost for the vitamin D deficiency-related diseases. Cities, in addition to promoting sedentism, the atmosphere of some cities filters out a lot of UV, especially the short wavelength ultraviolet B radiation. The canyons that we find in many cities effectively eliminates sunlight from the ground level. Indoor environments, again, fluorescent lights, at best provide some illumination, but provide no other benefit, and sometimes can be, if they're too blue, can actually stimulate our alertness centers too much, so it ruins our sleep patterns. And in a great departure from whatever we did in prehistory, we now mostly wear concealing clothing. Sewn clothing, mass-marketed clothing, clothing that we change all the time and we make into fashion statements. It's great, it's part of human culture, but it's changed our relationship to our physical environment completely. And in some cultures where concealing clothing is religiously mandated, the concealment is complete. And this changes the nature of the biological interface entirely. The vitamin D compromise is now also broken because we have reduced consumption of vitamin D-rich foods. In many parts of the world, vitamin D-rich fish have been depleted from the sea. The codfish that the Scots ate in early history and into the 20th century is now mostly depleted from the North Atlantic and the North Sea. So people are eating fish in this form, often white fish, often other types of fish that have no or virtually no vitamin D content at all. So you might feel a little bit noble about eating something like this, as opposed to a basket of McNuggets. But there's very little virtue involved and no vitamin D. And for darkly pigmented people, the vitamin D compromise, especially in cities, has been broken. Because dark pigmentation being such a natural sunscreen, such an excellent competitor with photons, it absorbs all the UVB that might have been used to convert 7-DHC in your skin to pre-vitamin D. Combine this with living in low UV environments. Think about people living in London, Boston, or even just living indoors most of the time. The combination of dark pigmentation and low UVB environments is critical and has resulted in what we recognize now as truly an epidemic of vitamin D deficiency in darkly pigmented people, especially those of African origin. So when we look at our model of skin, here is, again, our epidermis with dark pigmentation. Here's ultraviolet B and ultraviolet A coming from the sun. At the equator, there's a lot of both, but UVB is being scattered and absorbed by the atmospheric oxygen and ozone. And here, most UVB is being absorbed by the beautiful eumelanin in the pigment here in the lower epidermis. And then what is happening is that some vitamin D formation is occurring. So if someone is outdoors long enough, even with this beautiful natural sun protection, ample vitamin D would form in the skin to adequately meet physiological needs. But as soon as UVB levels are lower as a result of change of lifestyle or change of location or both, all of a sudden, this dark pigmentation, which competes for photons, for UVB photons, will entirely prohibit any UVB from penetrating into the layer here where vitamin D is formed. So this, we looked at in an evolutionary context, was the reason that we see the evolution of depigmentation in lineages of Western Europeans and East Asians. But it is one of the reasons today that we see vitamin D deficiency in people of dark pigmentation especially, because this beautiful sunscreen layer is doing its job when we wish it wouldn't. So what happens to vitamin D production in the skin when it's low or when people live inside? Basically, it doesn't happen. And we end up with people at best that have seasonal peaks in vitamin D levels. In order to study this more fully, we took our study, a clinical study, to South Africa, a country that I've been fascinated in for years, because it is a country and a region that is one of the most lavish and deeply historical melting pots in the world, where people through the Bantu language expansions of 5,000 to 3,000 years ago have moved into Southern Africa. We have indigenous peoples who have been in South Africa, the San and Khoi peoples, for more than 70,000 years. We have Europeans coming almost 500 years ago, and soon thereafter, waves of immigrants and slaves coming from Madagascar, Java, and India, all converging on the Western Cape of South Africa initially, and then branching out into the rest of South Africa. An incredible mixing pot of cultures, languages, and skin colors. And I thought, what better place to look at the factors that influence vitamin D production than to take some samples of healthy young people and monitor their vitamin D levels throughout the year. What we did also was we measured levels of UVB in the atmosphere. So instead of relying on indirect satellite measurements, we actually looked at on-the-ground UVB, and because our study was focused on what was happening in the very extreme southwest corner, occupied by Cape Town and other polities nearby, this area is particularly bereft of sunlight in the austral winter, something that very few people appreciate. South Africa is a big country and there's a tremendous gradient of ultraviolet radiation. But the southwest corner is very low, especially in the winter. So what happens? What happens to people's vitamin D levels when you've got all these different kinds and colors of people living in a highly seasonal UVB regime? To make a long story short, they experience seasonal vitamin D deficiencies. So this vitamin D formation in the wintertime disappears entirely. People aren't eating vitamin D rich foods. They have very little access to them. There's no vitamin D supplements that most people can afford, so they enter into these troughs of vitamin D deficiency. What happens? When your doctor talks to you about vitamin D deficiency, they sort of wag their finger and say, oh, you're going to be susceptible to colds and flu and all sorts of things. In South Africa, that is also true. But in South Africa, where there is high prevalence still of HIV-1 virus and high prevalence of tuberculosis, the stakes of infectious disease are much higher. So if your immune system is weakened because of vitamin D deficiency, you don't just get a sniffle, you might actually contract infection from the tuberculosis bacillus. Or if you're an HIV-1 carrier, you might convert into an active AIDS patient. So vitamin D deficiency becomes a much higher stakes problem. Low winter UV leads to extremely low vitamin D levels. And what we found, it wasn't just low UVB, but the fact that people stayed indoors more in the winter. So regardless of what their skin color was, the fact that they stayed indoors more and didn't have access to the ambient UVB when it was available made a big difference to their ultraviolet B exposure and their vitamin D production. And in a paper that we published a few years ago in the Proceedings of the National Academy of Sciences, without going through a lot here, we were able to show that actually when we were able to study the replication of HIV virus outside of the body, when we took blood samples from people, looked at their vitamin D levels, but also cultured their blood to see what levels of virus could be cultured under different vitamin D levels, what we found was that HIV-1 virus proliferated under conditions of vitamin D deficiency. So low winter UV led to not only extremely low winter vitamin D levels, but increased susceptibility to HIV and TB infections. This is something now that we are continuing to work on. The problem of lack of vitamin D production is now a problem even if you don't have darkly pigmented skin. Lots of people with moderately and lightly pigmented skin are vitamin D deficient simply because they're not getting outdoors very much or because they're very attentive in their use of sunscreen. These things are very important. Protecting your skin against ultraviolet radiation is important. We are long-lived animals. We don't want our skin to deteriorate. But we have to recognize that if we're not getting our vitamin D from the sun, we have to get it from some other sources. And vitamin D deficiency is now a serious global problem. But what happens to this other interesting molecule in the skin that is produced and released in great abundance when the sun and ultraviolet radiation impinges on the surface of the skin? Nitric oxide. Recall that nitric oxide is released in the skin by ultraviolet A radiation. The release of nitric oxide in the skin is made possible by our friend folate, the B vitamin. Nitric oxide is released in the skin, and it allows the peripheral arteries to dilate, thus providing fluid to the eccrine sweat glands so that we can maintain thermoregulation, and helping to control blood pressure. What happens if people are indoors all the time? Nitric oxide isn't produced as much, and vasodilation does not occur. In fact, you can have chronic vasoconstriction under these circumstances. And whether you have darkly or lightly pigmented skin, the problem is real. Peripheral vasoconstriction as a result of lack of sun exposure. My colleague Richard Weller at the University of Edinburgh, as well as my colleague Larry Kenny at Penn State University, are involved in studies looking at the cardiovascular benefits of sunlight that are independent of vitamin D. And I'm collaborating with both of them very happily because I'm trying to figure out how this all worked out in evolutionary history and how it matters now to our health, and why we have to pay attention to the evolutionary fundamentals in order to lead healthier lives. We evolved under the sun, and the changes in our lifestyle we have to think about very carefully. The skin is our primary interface with the environment. It has been, it is no longer. We need to sort of renegotiate. We have to strike a new compromise between behavior, diet, and culture to improve health and well-being. But do we go cry in our beer because, oh, woe is me, we have social problems, we have color-based race problems, we have health problems related to skin color? No, we don't despair, because we are thinking humans who prize education. And one of the things I'm involved in really happily is the production of a book that will be published by David Philip Publishers in Cape Town in July about the evolution of skin pigmentation for school kids in South Africa. It will initially be published in 4 of South Africa's languages, and by the end of the year in the official 10 languages of the country. We can also, closer to home, teach kids about diversity, about human evolution, about how all of this history has played out and brought us to where we are today. This is possible. This is a view from one of the summer camps that I have been running with Henry Louis Gates Jr. in the last few years in a project that we call the Finding Your Roots Project and the Finding Your Roots summer camps. We have brought together over 30 scholars from Penn State and other institutions, into human geneticists, education specialists, bioethicists, historians, many different folks, to put together a curriculum initially in informal science education, middle school summer camps, where kids come and discover themselves. We talk in this country not only about problems of race, but problems of inequity in education. of problems of young individuals, Latino, Native American, African American, not going into science, mathematics, engineering. How can we improve these outcomes? People have been beating their head against many good doors for years, and we decided to try something a little bit different. And through this Finding Your Roots curriculum, as it now is, funded by the Robert Wood Johnson and Rockefeller Foundations, and also recently by private philanthropy, we have the beginnings, I think, of a mode of inquiry that we can introduce not into universities, not into high schools, but into middle schools, and not just into informal contexts, but into our classrooms. This is exciting. We can teach kids about themselves. We can have them discover the wonder of their own DNA, their unity to others by looking at similarities in their genomes. Being with these kids is incredible. Having them discover things about themselves, having them discover things about lumbriculus worms under the microscope, about their ancestors in the paleontology lab is very exciting. And we leave them to conduct their own experiments. By the end of the summer camp, they are scientists testing hypotheses themselves, having the confidence to investigate. They are scrutinizing data, talking about variability. And yes, in the United States, we have kids talking about race and talking about why people look differently and how race is a social construction and what that means. And when kids are 10, 11, 12 years old, they aren't freighted with all of the hang-ups of adulthood. And it is marvelous to behold. There is a lot of hope. We may not be able to vaccinate people against ignorance, but we can use childhood education as a form of vaccination against antiquated views on human diversity, human evolution, race, and health. There is lots of hope. I want to thank very much the organizers of this lecture series for this generous invitation. Thank my husband and primary collaborator, George Chaplin, who's in the audience today, my superb research assistant, Tess Wilson, for lots and lots of help, Ellen Gobler, who was the logistic coordinator for this series, tremendously, Leslie Hlusko, tremendously for the role that she played, and another person who isn't on the credits list here, but Blake Edgar, who is in the audience, who was my editor at the University of California Press, who shepherded my 2 books, popular books, to press, and who continues to be a great guide and inspiration. Many other people, many foundations provided support for me. I would be happy to send you, if you write to me, any number of publications, maps, and other things that might interest you. You might find some of them on my website. I am always available. Thank you very much for your attention.
Dr. Jablonski, that was really dynamic. Thank you so much. As I mentioned yesterday, my wife and I want to move to University Park and sneak into some of your lectures so we can hear more of you. But my question is this. As humanity continues to move into urban areas, as we continue to cover ourselves with clothing, not just our bodies, but our head, is the evolution, well, from a natural selection perspective, is our evolutionary result going to be lighter skin?
It's a very good question, and the answer is pretty simple in that we see no evidence of natural selection promoting depigmentation now, largely because there is very little evidence of people losing out in the reproductive sweepstakes as a result of living in cities without sun exposure. So there might be some if our epidemiological studies were good enough, we may be able to detect some signal of sort of loss of fitness as a result of urban lifestyles, but not enough to promote changes in gene frequency, leading to changes in pigmentation. But what we do see in urban environments, and this is one of the beautiful parts of the Bay Area, literally physically beautiful, is that we see such lavish admixture of people. People from all different parts of the world come together, share interesting cultural things, have children together, and produce new genetic combinations and new phenotypes. And often these phenotypes are lighter than at least one of the parents. So we aren't seeing natural selection produce loss of pigmentation, but we are seeing sort of a mingling and an increasing number of pigmentation intermediates being produced in many urban centers in the world.
I was fascinated by your graph yesterday of decreasing hair in our hominid line as in more recently millions of years. And that raises two questions that I wish I had asked yesterday. One is that as I follow your discussion of hairlessness and thermal regulation, I wonder if actually losing hair gave our ancestors a flexibility to exploit a much wider range of environments than other primates who had more hair. In other words, the loss of hair actually gave humans a lot of flexibility to go into a lot of very, very different environments. And my second question about hair is one thing that we've noticed in nutrition, and that if you're feeding an animal like a mouse or a rat that's full of hair, you have different requirements for sulfur-containing amino acids. And I was wondering if there was actually a nutritional component in the loss of hair in our own ancestry.
Yeah, good questions. In answer to the first, I think much of human versatility and our ability to disperse and adapt to a wide range of environments is due to our incredible technology and behavioral flexibility and our incredible inventiveness, which we have had since the beginning of Homo sapiens and probably even further. When we look at the cultural sophistication of Neanderthals and ancestors of Neanderthals that were living over 200,000 years ago, and modern humans in Africa and outside of Africa tens of thousands of years ago, basically what you have is a rich material culture and a rich culture of the mind that allows people to live in places and under conditions and following lifestyles that other mammals cannot achieve. So I think skin has played a role in that it's given us a different mode of communication, cutaneous communication, communication through our raiment, as well as our body decoration, has given us greater versatility. We just don't have one outfit, like, a dog or a cat or a cow might have just, sort of one fur. We have many. So we're able to express our individuality, our group identity, through how we adorn our naked bodies. And I think that has been part of the cultural adaptation to different environments. In connection with diet and hair, the biggest things that we notice in humans, of course, are gross protein deprivation and the effects on hair leading to hair breakage and the conspicuous sort of red pigment that you see in infants and children with kwashiorkor. Other nutritional benefits are not that well understood. And there are all manners of diets that people now subscribe to for better hair, making your hair more luxurious, less kinky, more wavy, what have you, by eating certain foods. The extent to which diet, beyond providing basic amino acids, the extent to which modifying diet is going to affect hair texture and curl is really unclear. So there's a lot of sort of bad science and pseudoscience about this, but I hope, largely or partly through the work of graduate students in my lab, that we may be able to understand some of these factors a bit more in 2 to 4 years' time.
Hi. I actually have a burning question. If
Please.
you could talk a little bit more about the difference between vitamin D3 and vitamin D2.
Yes.
And because I'm really curious about two things. One is as we move to fortify milk, and I actually don't know much about that history of when we did that and what was the impetus for doing it, how much of a health benefit has that conferred? And then also, is that actually adequate to help circumvent some of the deleterious health effects?
Yeah, really good questions. Vitamin D2 is a form of vitamin D that is produced primarily in plants. When we ingest it, we can use it, but it has to undergo an additional hydroxylation step in the liver. So vitamin D3 is the more common animal origin vitamin D, although there is some vitamin D3 in some plants, but vitamin D2 is the more common. Both of them are potentially usable, but both of them, when we ingest them as food or as supplements, have to undergo the rigorous conversion in the liver, in the kidney, and that final step of chemical conversion in the kidney to the active form of vitamin D. That can occur from a vitamin D2 or D3 precursor, and that is the most rate-controlled step in the body, so that you can produce a lot of vitamin serum D3 in its storage form, but then the activation to active D3 that occurs in the kidney is extremely highly controlled. But these days, most supplements are of vitamin D3. There are fewer of D2. In answer to your question about fortification in milk, milk fortification was introduced in this country widespread after World War II, when the importance of vitamin D in preventing rickets in infants and children was widely recognized, and it was a public health remediation that was initiated similar to that of fluoridated water for the public good. In this country, most milk that you buy is vitamin D fortified, but the amount of vitamin D varies from one brand of milk and even from one batch of milk to the other. The level of vitamin D fortification is enough to prevent the most severe level of deficiency, but not to provide physiological adequacy for a child or an adult, unless you drank prodigious amounts of milk that would be dangerous from the point of view of drinking too much calcium and putting you at a risk for kidney stones. So the vitamin D3 fortification in milk is very helpful and could be used as a model for other countries. There are lots of places where milk is not vitamin D fortified and where this would help to sort of lower the prevalence of vitamin D deficiency in some very vulnerable populations. But that level of fortification is not adequate to meet physiological needs, so that one has to have other vitamin D rich foods, of which there aren't very many. Oily fish is the best source, but there are very few genuinely oily fish around. And so today, most people really have to rely on vitamin D supplements and occasional prudent sun exposure.
You timed your visit well. You joined us in a sunny interlude in an otherwise very dark winter. And that prompts my question. I notice a lightening of the mood when the sun is out.
Yes.
And I wonder whether that mood sensitivity to sunlight could be related to a person's, the location of the evolution of their genotype.
This is a great question, and many people have been interested in this in trying to understand the biological basis and the genetic basis for seasonal affective disorder and the role that vitamin D might play. This is it's a fascinating and complicated answer. I'm going to give you the short version. What we have in our retinas of our eyes are not only the 3 kinds of cones that allow us to see beautiful trichromatic color vision, but we also have a specialized subset of cones that are blue light receptors. So on a bright day like this, there is a lot of very short wavelength visible light that stimulates the blue light receptors, that makes us more alert, that communicates with our pineal gland, that communicates with our pituitary gland, that communicates sort of the global sort of endocrine switches are turned on. And many of these lead to elevation of mood. Beautiful work has been done comparing the prevalence of seasonal affective disorder in places like Iceland versus Ecuador. And what is found is that there are real differences in the amount of blue light that stimulates the body, and that this seems to be one of the most important arbiters of mood. Vitamin D also contributes, but interestingly, it is not probably the primary contributor to seasonal affective disorder or the sort of the high that you feel. Rather, it's the stimulation of your blue light receptors.
I think milk was the wrong thing to fortify because 50 million people in the US are lactose intolerant, and
Yes.
most African Americans are lactose intolerant.
Yes.
So we should figure out what to put vitamin D in. Now, I've been converting lots of people to take vitamin D, and if they're deficient, they really feel terrific
Yes.
afterwards. So there is, whether it's Danes, I was in Denmark for a scientific meeting, and Denmark has, Copenhagen has about the worst climate in the world,
Yes.
at least compared to Californians. And there was a sunny day, and the whole city stopped.
Yes.
Everybody had taken off most of their clothes. I must say more clothes were taken off than an American would. And there were all these half-naked bodies all over the city
Yes.
all day.
Yes.
Everybody was nobody was in the shops, nobody was doing anything but sunbathing. And I asked a Danish scientist friend, how come you do this? And he said, well, we Scandinavians get so little sun
Yes.
that whenever there's sun, we sunbathe because we feel terrific afterwards.
Yes.
And I've had personal experience with African Americans who have gotten to take vitamin D, and they feel terrific.
Yeah.
So I think that's something that'll help getting
Yes.
it into everybody.
And, in connection with both of your points, first of all, getting a vehicle other than milk is important. In South Africa, there is fortification of some margarine. Unfortunately, you would have to eat a huge amount of margarine in order to benefit from the vitamin D fortification. One of the problems is that vitamin D is oil soluble, so you can't easily sort of put it into fortified cereals or orange juice, although people do put it into the orange juice suspensions, but it's a difficult molecule to deliver in a fortification of a normal food. But your point about Denmark is a very interesting one, because there they have refused to fortify their milk. So there is no baseline fortification of milk or any dairy products, and people can only get their vitamin D either from fish or by taking off their clothes. And they really, you have sort of I don't want to impugn the Danes at all, but people sort of going to their Paleolithic sort of past to expose themselves to sun. And I think what's interesting there is that when people are exposed to the sun that their ancestors were used to, if they gradually sort of gain and lose sun exposure or UV exposure, their skin changes and they're able to maintain UV or vitamin D adequacy. And in a country like Denmark, when people were outside most of the time, even though they had vitamin D in their diet, they got a lot of their physiologically important vitamin D throughout the year from episodic but regular episodic sun exposure.
They were also eating a lot of fish.
Yes, much of which doesn't exist anymore or is too expensive for most people to buy.
Now, vitamin D isn't that expensive. It's
here, now, today, in the United States, vitamin D is cheap. You can go into any supermarket, any health store, and get these huge bottles of, for $10 or less. But go to Europe, go to South Africa, and try to buy vitamin D. It's not bulk processed there, and a little bottle of 60 capsules will cost you $20. Or it'll cost you more than that in South Africa because it's imported from the United States or Europe, and it's more than a week's wages.
Yeah. But at least in fortification and telling people here, you can buy vitamin D.
Yes.
And it's not that expensive.
Yes, and I think this is something where the medical establishment is moving significantly and importantly to recognize the importance of vitamin D supplementation. It's not the be-all and the end-all. It's not a panacea by any means. But raising people off of baseline deficiency will greatly improve health outcomes, not only in the ways that I've described, but in many others.
No, I've been digging into that for years now, and there's a huge, I think, dark-skinned people are carrying a big weight on their back, and vitamin D is going to help.
Yes.
Well, thank you. If we have no more questions, if we could do a big round of applause and a thank you for Nina.